The topic for the presentation is a comparative studies of flammability properties of new and old wood. The authors are JiangL, that's myself, MensahRh, and XuQ. The author is JiangL from Nanjing University of Science and Technology, China. The content of the presentation is as follows. First, I will give a brief introduction, then move on to the experimental process, talk about the results, and finally, the conclusion. Abstract. 3 species from new and old cypress, pine, and fir wood were selected to evaluate the potential flammability among the species by using small and bench scale experiment. Based on the measured flammability parameters, pine and fir wood had higher peak heat release rate, shorter ignition time than cypress, which had an increased residue about 20% higher than the other species. More hazardous gases and smoke production rates were recorded for new wood. Each variable analyzed was significantly affected by species considered with its density. The ignition time will decrease as the external heat flux increases. Introduction. Wood is considered one of the most oldest and most important building materials, and as a standard renewable energy, sustainable resource in construction. Architects around the world are increasingly using wood for construction and manufacturing of furniture, wall decors, paneling, roofing, and so on. Wood in any form, either fresh or old, are used in various applications having remarkable properties such as small bulk density, low thermal conductivity, good mechanical property, etc. However, wood is a combustible material. With its inherent flammability, poses fire risks which may lead to injuries, accidents, loss of life, properties, and so on. With its vast benefits, there is therefore the need to conduct flammability studies to improve the fire safety of the wood material. Methods. The fire risk of flammable is a key factor in effectively evaluating combustion performance for materials exposed to fire conditions and can be evaluated by ignition time, heat release rate, mass loss rate, speed of propagation, hazardous gases, and etc. In this experiment, 3 species of wood were selected: cypress, pine, and fir for comparative studies. Among them are new and old wood. There are many techniques to measure flammability parameters. In this experiment, thermal gravity test, microscale combustion calorimetry for both method A and B were employed. Cone calorimetry test also considered. For thermal gravity test, it is used to study the thermal stability of the wood material. And then the microscale combustion calorimetry are also used to evaluate the heat release rate, peak temperature, time, char yield, etc. The cone calorimetry test are also used to determine parameters such as ignition time, heat release rate, mass loss, and other properties relevant to fire characteristics. All the methods comply with standard protocols. Result: thermogravity test. Figure 1 and Figure 2 shows a typical mass loss curve of new cypress wood and old cypress wood in air environments at different heating rates. From the TJA result, the curve showed three stages of thermal decomposition from the wood samples. For wood pyrolysis, thermal degradation occurred in the three main components, that is, the hemicellulose, which decomposes first, the cellulose second, and then the lignin. The mass loss rate percentage of the initial sample is displayed as a function of temperature. Here, the old cypress in air environment experience a wide range of temperature at 430 degrees Celsius to 798 degrees Celsius due to lignin content, which is thermally stable. And then it also generated about 20% more char residue than the other wood samples. Microscale combustion calorimetry test. The heat release rate curve in Figure 3, 4, 5 with different sample mass at the same heating rate exhibited a typical shape expected for the wood samples. In Method A, a single peak is shown for the samples. It is evident that, although each species group follows the same general shape, differences can be observed with regards to the peak height, width, and the temperature at which they occur. For example, cypress wood has the lowest heat release rate value recorded at 118, followed by fir wood, and pine recorded the highest peak heat release rate, depicting high flammability. Figure 678 shows a typical heat release rate curve with different samples mass under a single heating rate 1 Kelvin per second for Method B. The curve indicated two peaks, where there is an initial increase to a peak and a drop of heat release after a char layer has been formed, then a second peak that corresponds to the increased production of the volatiles from the remaining of burnt wood specimen. This behavior is also attributed to the test procedure. Here, cypress wood again recorded the lowest peak heat release rate, depicting low flammability. Cone calorimetry test. The cone calorimetry test results observe some differences in time to ignition, peak heat release rate, ignition flameout among wood species. The initial heat release rate for new wood was slightly higher than the old wood, although the second peak of old wood was higher, recording about 225 kilowatts per meter squared. Additionally, the smoke production rate for old wood was reduced after 300 seconds. It was seen that the new wood had an increase in average carbon monoxide and carbon dioxide yields, which may be attributed to moisture content of the sample. As the external heat flux increases, the residue percentage also decreases. Conclusion: 5 properties of different species of new and old wood were obtained. TJ analysis in air environment were slightly lower than nitrogen environment for cypress wood. MCC experiments in Method B showed a significantly higher peaks of heat release rate than in Method A. In cone calorimetry test, the result shows that the differences in densities and the type of wood resulted in a significant variations in flammability parameters. Again, there was a slight improvement observed from time to ignition, low heat release rate for cypress wood. Thank you for your attention.